Hand those up and over now. When you came in, you all should have picked up two packets. One of them is the note packet for this unit. Then the other one is the homework packet. I'll tell you this. I didn't know whether or not this was going to jam the copier. It kept breaking down. So I believe if you go into the Google Classroom, this is posted. The homework packet, if you want a bigger version of it, is posted. So we'll tell you this. Because there was a noticeable, we'll say that the data from the class was very bimodal, which means that if I'm looking to plot out what your grades are, it sort of starts to look like a camel. There's two humps. That's what bimodal data is. So in order to bridge the gap, because I had a couple people who came in and were going, oh, this is so difficult. And I said, okay, we'll work together. But the first thing I said was, can you show me the ones that you did on your own? And I thought we went over it before, but it was kind of interesting because somebody last year did like the same thing, and they go, well, I didn't understand the homework. Well, it's in my locker. I go, terrific. I've got nothing but time. Head over to your locker and go get it. And then they changed to, oh, wait, I didn't do it. So on the front, you're going to see a schedule of assignments that are to get done, to get completed. Make sure, please, that, like on the first day, you can see it says to go through and do day 1. Your homework is page 67 through 69. Numbers 10, 27, etc. Now, I didn't give you a book. Let's say this. Who would like a giant textbook? Who likes not having a giant textbook to carry? Okay, fabulous. So what you have instead is that I took the time to scan the pages and cut them into one single document for you to use. So that's what's over on the right-hand side. And sometimes, on some of the days, I have an extra question or two. And I think I have one for today where it gives you some points and it asks you to connect to what you did in geo, like an altitude or something like that. Yeah, write the equation of the altitude from C. Gives you those coordinates. And your questions, though, are over on the side. So make sure, please, that you keep this. There's an extra copy of it posted in the Google Classroom, but that needs to get done. So the other thing that we have you do now is make sure this great big giant packet is out, and go through and make sure that you have signed in to your calculator. There's still some of us that haven't, so if you haven't signed in yet, go through and make sure that gets done. Remember your username. If your name is Bob Smith, your username would be B Smith. And what is the password?
1, 2, 3.
There you go. Your password is 1, 2, 3, 4. So make sure, please, that you have all of that stuff. This is going to be the first stuff that we do, and I guess eases you in maybe a little bit too much, but in any case. So the first thing that we're going to review is linear functions. A linear function is any function whose graph is going to be a straight line. Now, there's also something called a constant function that we're going to go through and look at. A constant function, when you graph it, is also a line. We like to say, mathematically, that a function has either one or two variables with no exponents or powers on the variables other than 1, because 1 is implied. So, when we're talking about things that are linear, a linear graph, or a linear equation could look like y is equal to x. Y equals, let's say, 5 plus 3x. Notice that there's no powers greater than 1 there. We could use function notation and say f of x is equal to 5x plus 2. Those are all linear. Now, things that are not linear, let's say I have y equals x squared plus 3. Hands up, please, if you can tell me the type of graph that would be.
Quadratic.
There you go. It's going to be a quadratic. How about if I have something like this? You have y squared is equal to x. Does anybody know what that's going to be? Go ahead. What's that? No? because it's not y to the x.
It's a parabola, but it goes sideways.
Perfect.
C or a whatever vector C is.
This. Understand a couple things that we're going to get into. Did you do what a function is and what a function isn't before? I'm going to guess no based on the resounding answer there. If you have a line, and the lazy definition is if the graph of it passes the vertical line test, then it's a function. So if I graph this, this would be a diagonal. This is a line with a slope of 3 and a y-intercept of 5. That's going to be linear in a function. This would be a function. A parabola is going to be a function. If you think about what they look like an upside-down arc. See the one in the back there? And we're going to try to make these change throughout the year. So seeing as we started off with factoring, and we factored quadratic and polynomials, so that's what a quadratic looks like upside down. That would be a function. If I change the variable around, though, and made it be, instead of y equals x squared, if I made it x equals y squared, our parabola would open either to the left or to the right instead of opening up or down, and would not then be a function. Anytime you have a y squared, it's not going to be a function. And it's definitely not going to be linear. These are what some linear functions look like. It's the expectation to be able to see them again. These are all linear. Notice as we go from term to term, let's say this, as I go up, I might jump by 2 each time. From here to here, my outputs go up by 3 each time. Notice the x jump is constant, presupposing you can recognize this. All of these are linear functions. This is not. This would be a quadratic. This is exponential. And notice as I go from here, I went up by 5. Here I went up by 10. Here I went up by 20. Same thing here. I go up by 4. I go up by 6. I go up by 8. These are not examples of linear functions. And a linear function, the rate of change is constant. Questions on that? Yep.
How do you know if it's a quadratic or exponential when just giving some positive,
If it's exponential, the variable is in the exponent spot. If it's quadratic or some polynomial.
What I mean is, if you were just given a table, how would
you would have to go through. Properties of exponentials is that you go up by a constant multiple. So this right here, as I go, how do I get from 5 to 10? Well, you could, if it was linear, I would be adding 5 each time.
Yeah.
And the plus 5 here would be another plus 5 here and a plus 5 here. As I go from 5 to 10 and 10 to 20, the gap between them is not constant. So as we go from 5 to 10, what did I do besides? You could say that you added 5, or you could say that you multiplied by 2. And if that's the pattern that it fits, that's what's going to happen. So if I multiply this by 2, the next gap would be going up by 40, then 80, and so on. So that's how you can spot the difference. Now, to start off with, we're going to give you slope-intercept form, and this gets profoundly frustrating because you all love slope-intercept form. Lines in slope-intercept form, you can easily identify the m, which is the slope, and the b, which is your y-intercept. So you have to understand that the m is the slope, or your rate of change, and that's a calculus term that you're going to have to get used to hearing. The b is your y-intercept. So this would look like y equals, let's say, 2x, or y equals 5x minus 3, something like that. That's in slope-intercept form. You can easily look at it. The first one has a y-intercept of 0, slope of 2. The next one has a y-intercept of negative 3 with a slope of 5. So as you go through, this is going to be, you have to be able to recognize it. Some of you are a little bit, you struggle with the Cartesian plane, and the Cartesian plane is the plane that you were graphing on the XY grid. When you do something like this out, you need to recognize sometimes you'll be given a point and you'll think it's one thing. You've got to recognize that it's giving you at 0, comma, some b value, that's going to tell you what the y-intercept is without saying the y-intercept is 4. You could say it goes through the point 0, 6, and you've got to be able to recognize your y-intercept would be 6. And your slope is the change in y over the change in x. Now, here's the easy definition of it, or I guess the coordinate geo one. We would say y2 minus y1 over x2 minus x1. The change in the output over the change in the input, the change in the range over the change in the domain. The other one, and I don't know how familiar you all are with this, if you are given, and by the way, this is another one that gets a little frustrating. This top one, it's the easiest equation to get if the question gives you a point and a slope. The first one is if you're given the slope and the y-intercept. If you're given any point on the graph, not a y-intercept, but any point on the graph, along with the slope, you use this formula here. Now, just a quick survey, it's not going to change anything, but have you all worked with this formula previously? Raise your hand if it's a yes. Okay, so it's going to be y minus y1 is equal to m times the quantity x minus x1. The m is going to be your slope. And the point x1 comma y1 is any point on the line. So as we're doing this, it doesn't matter at all what your y-intercept is. It doesn't impact what the equation is in the least. An equation like this, or in this format, would look something like, let's say, y minus 5 is equal to 1/2 times the quantity of x plus 3. If you're given that, let's see if we can identify looking at what we have here, hands up please if you can tell me what your slope would be. Given the equation in this form, we'll wait for 7 of you. Look at what's there. What's your slope going to be? We got 4 or 5? I say. Oh, sorry, what did you say? Now, looking at that, who can tell me what the point that this graph goes through is going to be? It's going to be an ordered pair in x comma y. What points does this graph go through? Look at the coordinates. What do you say? Go ahead.
-3.
So we would go through and say this goes through the point 5, -3. And the reason that this 3 here is positive is because it's minus the -3. Questions on that? Now, from what we have here, the next thing, all of these equations below represent the exact same line. Looking at what's there, I could represent this line by saying y equals now the slope, and you have, here's another thing I would change if I was ruling the world. Instead of saying you get this lazy representation, and everyone always screws it up, instead of saying if you're given 2 points, they go through and they say, well, it's rise over run. Raise your hand if you've heard that before. Okay. Imagine, right, you all have very, very young brains. Imagine if I had like 30 kindergartners right now. Like imagine instead of you all, it's 30 kindergartners. Right. And then I say, all right, run. Not just like there's an explanation. Just run. Which direction would those kids run in? Out the door? What if we were outside? What if we were on the turf? And they're all sitting in a circle. You said, run. Are they going to run in the same direction? No. That's why instead of that, we're going to say our slope isn't rise over run, it's rise over right. Because that's an actual tangible direction, and it's a very easy way for you never to screw up whether a slope is positive or negative. Now, when I'm doing out a slope, I always pick a lower point, then work to an upper point. So if I were to pick out 2 points, I'd say, all right, here and here, I'm going to do rise over right. So I go up 1 to get to that point, and then I go right. Well, my slope here, my rise is 1. My right value is not 2. Because did I move right? Which direction did I move? When you move left, it's going to be negative. So it's the most missed thing on the Algebra 1 exam, whether a slope is positive or negative. It's the one that falls furthest below what the expected standard is every year. So that's how we handle that. Make sure you got it as rise over right. For the first one, this y equals mx plus b is one equation of a line. And again, this equation right here is called slope-intercept form. So we've got our slope of negative 1/2 and our y-intercept. I look at the graph, and this comes out to be a value of positive 5. Now, if you're using the point slope formula, you're not constrained, or you don't need to know the y-intercept. Any point works. So I could say it's going to be, notice the slope here is the same every single time. All of these here are going to have the exact same slope. What's changing is the ordered pair that I'm working with to get them. All 4 of those lines mean the exact same thing though. These ones right here, you've got to recognize are in point slope form. There is a difference, and if you give your answer in the wrong form and it says one way and you give it the other, you don't get points for it. Questions on that? All right. Looking over, another thing that you need to know is a horizontal line's equation and its slope is compared to a vertical line. Now, I'm going to tell you this, and this is one secret that I have. We have calculuses, we have students at U of I, top 35 in the whole country, that don't know what a y equals line, y equals a constant, or an x equals a constant line looks like. And if you write it out this way, I can almost guarantee you, after seeing it this way, you'll probably never get it wrong. A y equals line looks like that. An x equals line looks like that. So there's y equals lines and x equals lines. If you don't remember, that's the easiest way to go through and do it. You won't be getting it wrong if you're thinking, well, the line goes side to side. Is that y equals? Remember, y's go to the side. X is like the letter X when you draw it out that way, go up and down. So the first thing that we'll talk about is a horizontal line. Now, if we're thinking about what the coordinates on that point would be, you could also view it in terms of like a coordinate definition. Let's say this is the point, let's say negative 5, 3. This would be the point, let's say 2, 3. This would be the point, let's say 7, 3. Those 3 points on that horizontal line, they all share the same thing. They all share the same y value. So it's going to be y is equal to some constant value b. In terms of slope, think of it as rise over right. In this case, am I ever rising? No. So you'd have 0 over something, which means your slope, doesn't matter what it's over, 0 over anything is going to be 0. Questions on that one? Now let's bounce over and try the other one. If I were going to do this out as an x equals, or sorry, look at this vertical line in terms of its coordinates, I could say, here's a coordinate here, we'll say it's 1, 7. Another point that maybe this could be would be 1, 4, and maybe down here you've got 1, negative 1. All of those have the same value as well. They all share the same x. So our equation would be whatever x equals in terms of a number. So in this case, we're talking about the point A comma B. Now, another issue that we get is what the slope of an undefined line of. The slope of a line that is vertical, we did rise over right. So my rise to go from here to here would be 5, and my right would be 0. So I take 5 over 0. Well, anything divided by 0, no matter what ordered pair you get, you'd still get a 0. That's going to be undefined. Questions on those? Yes?
Theoretically, wouldn't a vertical line be y equals infinity x?
No.
No.
Because remember, you have to have a number in there, and infinity is an idea, it's not a number. Take a look. Now, you all hopefully were good at this. Parallel lines are going to have the same or equal slopes. So an example of that would be if I had y equals 2x minus 5, and if I had y is equal to, now, over here, this is our first one. This is going to be y is equal to 2x minus 5. Over here, if I'm looking to figure out what this would be, I started off, my y coordinate was 3, so I go to y is 3, so that's here. Now, looking at this, we can generate what the equation of that's going to be. So looking at this, I'd say, well, this one right here, it goes through this point. I know that the y value here is 3. What was our x value at that point? Hands up, please, if you can count over and tell me what the x value would be at that point. We'll wait for 6 of you. We have 1 that can count. Terrific. 3. What do you want to say, please? -5. Now, if I'm trying to build this equation of the red line, you don't necessarily need to know what the y-intercept is. It goes through this point. Now I need to find my rise over right. My rise is going to be 2. My right is 1. So this would be y minus 3 is going to be equal to, we've established that our slope is going to be 2. And then we've got the quantity of x plus 5 because it was x minus 5 previously. Those lines are parallel. They have the same slope. If I wanted to get the other line in y equals form, I could, but that's something that we're going to sort of have to shy away from. Perpendicular lines are going to have opposite reciprocal slopes. That means the lazy definition, the one we want you to stop sort of, you can conceptually view it as, but if we ask you what you do, you don't take flip a fraction, you say take its reciprocal. And when you take the reciprocal of a fraction, you go through and the numerator and the denominator are transposed. So to start this off, I've got this line here, and that's going to be y is equal to 5/3 x. Now, if I'm trying to go through and determine the equation of the the perpendicular line, that would be this green one here. We could go through it and do it in a couple ways. Go through right now and give the equation of that green line out in slope intercept form. Go through right now and give that equation out in slope intercept form. Vicky asks. Vicky, did you get what this would be if you gave out the equation of the green line? What would your slope be?
-2/3.
No. Take a look at this here. If it's perpendicular, what do you have to do to this slope?
-3/5.
So that'll be what we start with. And then an x. What's after that?
+2.
Because that's your y-intercept. There you go. We have to be able to. Allegedly, you got through geo. Hopefully, they did lots of stuff with lines with you. This would be your slope. And it is -3/5. You've got to remember this, that 5/3 as a slope, the sign is perpendicular to -3/5. Over here, this tells you that the graph goes through the point 0, 2. Questions on that one? All right. Let's bounce over to the other one. Go through right now, actually, and do out these 3 questions on your own. Go through right now and do out these 3 questions on your own. If you need to go back and look at what's there, go back and look at what you've done. Michael, what would you get if you went through and did the first one? What's the equation of a line that has a y-intercept of 3 and a slope of 3? By the way, let's ask this first. Is it easier right now to use the point-slope form or slope-intercept form to get the equation of this line? Hang on, Michael? There you go, because we've got the y-intercept and the slope. So, Michael, what's that equation going to be? Done. Now, oh, I didn't give you the point. Sorry. Is that not on your paper? Sorry. Go through right now for B. It's got a slope of that and passes through that point. Now, looking at what's there, Chloe, does this one lend itself more easily to slope-intercept form or point-slope form? Why is it point-slope form this time and it wasn't before? Perfect. So when we do that out, here's here's your point-slope form. It's going to be y minus y1 is equal to n times the quantity x minus x1. So Chloe, what's that going to be when you make your substitution in? Now, there's one thing on here that I want to change, and it's the same thing twice, and it's okay in the beginning. Yeah.
-7, but then -5, so turn into a +7.
So this is going to be a +7, and what's the other part, though, that needs to change then? Yeah, let's go through and change this one to be x minus 1. It's tough to remember, but it's always the opposite of what those signs are in the ordered pair. Now the next one, this one's perpendicular and it's got to pass through that point. So, looking at what's there, Alexa, what would you go through and say? Would you use the slope-intercept form or the point-slope form in this case? Now, you could use either, but go ahead, keep going with it. So you're saying you're going to use y equals mx plus b, okay?
I said y equals -1/2.
Because this point here, you've got to remember from geo, if I graph this out, I've gone over 0 and up 2. That is your y-intercept. Now, there's another way that you could get to the same thing, and that's by doing y minus y1 equals m times x minus x1. You're not wrong if you do it this way. We go through and take our perpendicular slope, which means our slope here is 2 over 1, negate it, and go through and take the reciprocal. This would be y minus 2 is equal to -1/2 times the quantity of x minus 0. Now, you could give either one of these answers and be okay. If you kept doing the algebra out on this, you distribute the 1/2. Remember, x minus 0 is just x. This becomes y minus 2 is equal to -1/2 x, and then you add the 2 over to get y equals -1/2 x plus 2. Questions on that one? Next one up, we need to get the equation of a line, so let me get rid of these. We'll give you a minute or two to finish it. We'll let you do out. You should all be able to get A and B done on your own. C is a little bit tougher, but go through right now, please. At least get A and B done. If you analyze it, you should have enough info to get C done. take a look at the first one. And Colleen B. What do you need to go through and have before you can give out the equation of the line? What do you need that's not given? Yep. Do you know how to get, is enough information given to get the slope? What would you have to do?
I like took y myself and added 4.
Okay, so this now becomes y, 5y is going to be equal to 4x plus 20, and then what did you do next? So y would be equal to what?
4 x plus 4.
Okay. Now, it's got to be parallel to it, so what do you know about the slope of our line based off of this one? Good, so what's our slope going to have to be? Careful, we gave you one thing too much. Just 4/5, yep. Now, what would you do to give out the equation of the line?
Like what I wrote?
Mm-hmm.
I wrote y minus 3.
There you go. That's, what's that?
Oh, sorry, I wrote the wrong thing. I wrote 3.
Oh, you're talking about over here on the right? Okay. When you do this out, you've got to understand, this lends itself to be easier in point-slope form. Sometimes a question will mandate that it's in slope-intercept form. It really doesn't matter, though. They're equivalent to each other. Questions on that one? Next one up maybe is a little bit easier, maybe it's a little bit harder. If you don't know what this is going to be, I ask that you graph it out first. I give out a sketch that's perpendicular to the x-axis and passes through that point. So to start off with, I'm going to sketch out two sets of axes here. There's my y, there's my x. I go over 1 and down 4, so it's got to go through the point 1, -4. And the line that I go through and give is perpendicular to the x-axis, which means it's going to intersect the x-axis at a 90-degree angle. That means it's going to look something like that. So, based off of what's there, Courtney H., would that be an x equals or a y equals line? Good. And is it going to be, it's going to be x equals what? Now, hands up please if you can tell me what the slope of that line is going to be. We got 1, 2, 3 of you. Undefined. It would be 0 if it were going side to side. Now, C is a little bit more awkward. We don't know enough information right off of the beginning to answer out C completely. Hands up please if you can tell me what I need to do before I can give an answer in C. We've got 4, 5, 6 of you, 7. What would you like to say? Find the slope. You remember the formula for slope? There you go. So my slope is going to be equal to the change in y over the change in x. So if this is my x2, y2, this would be x1, y1. So looking at what's there, in the numerator I have 3 minus a -2. All over -1 minus 5. The numerator goes to, the numerator is going to simplify to 5 over, this will be -6. That's what my slope ends up being when we write it out. We'll pop that up to the numerator. So, Alyssa, what would you want to go through and give? Which equation do you want to use? Do you want to use the slope-intercept or point-slope form on this one? Okay, because you've got 2 points actually, so you could use either one of them and you know the slope. Which point do you want to use to give out the equation? Okay, so what would you go through and list out the equation of the line as?
Y minus 2 or plus 3.
Okay, is equal to?
-5, 6. X. Plus 1.
And I'm gonna, there's one thing we gotta have in there. Do you know what it is? Who knows what one thing I didn't go through and give? Yeah, so it's -5, 6 times that quantity. But that's right, and we got our signs right. Again, initially, it's always going to be a struggle. There's one piece of this, though, that I don't think is correct, that we've got to go through and change. And again, it's okay in the beginning, you're going to screw this part up, and it happens to everybody. What do you want to say? Yeah, because it's always opposite what those signs on the right are. So we'll change this over to a negative and be fine. You could have used the other point too, and if you did, it would be y minus 3 is equal to negative 5, 6 times the quantity of x plus 1. Questions on that? Either one of those, they're equivalent to each other. Now, take a look at the next one for 3. Go through, please, and read. You should be able to get, in all honesty, you all, I would expect to be able to get all 3 done, but at least the first 2. Read what's there, please, and bang out question 3. Who will? Oh, you Chris from the line? So, you got this person, they knit caps, they sell them at a fair, $5 to make each one. Weekly profit is modeled by that equation. What does the X in this case represent? Hands up, please, if you can tell me that. What do you want to say, please?
Money per day.
No. The X itself, the P of X would be what your end amount is.
Number of missed
Save that. What about the 50? Think about what's happening. What does the 50 represent? What do you want to say? The 7, see, because I'd say this. What is it? The $5. I wouldn't say that that's that piece of it. Yeah, it's like we'll say maybe an entry fee. Or your initial or startup cost. So like if you're going through and you're, building a restaurant, you've got to take into account everything that goes into the food in order to make a profit, but you also need to take into account your fixed cost, which would be the rent on the building or whatever the roof over your head is. How much must this person sell in order to make a profit? Well, that P of X represents a profit. So what equation would I need to go through, what inequality would I need to go through and set up to figure out how many I need to sell in order to make a profit? We got one person. Go ahead.
How does the P of X be greater than 70%?
So what we're looking to do is take the 7x minus 50, and do we need, in order to make a profit, do we need that to be greater than 0 or to be less than 0? We need our revenue to be greater than 0. That's how you stay in business. You need to be making more money than it costs, otherwise it's not running a business, it's volunteering. So go through right now and put in your answer, compute out what we would get for C. Or sorry, go through and compute out what our answer would be. Tyler, what did you get for an answer?
I got 57 and this one
So, here's one thing too where we start getting into, so it's 57ths, right? What did you say? Yeah, 57ths, because you went through, we brought this over, 50 is greater than 7x over 5 or 7. So now we get into the part that gets awkward. Who here has ever purchased 57ths of anything? I don't think you can. Like, I don't even know something that you could get 57ths of. So, let's ask this. Instead of that, you've got to put some of these in context. So, we go through and say, instead of saying 57ths, I would go in and say, we know that 57ths because this is just more than 7. Because 49 over 7 is 7. This is just more than 7. So if they sold 5 hats, are they making a profit? Yes or no?
No.
6 hats, profit. 7 hats, profit. You're almost breaking even, but you're still losing money at 7 hats. So how many do they need to sell?
8 or more.
Now, because this always comes up, there was one question on the exam on the Algebra 2 read a couple of years ago where they're talking about like deer in a field and how many are left at like a certain time. And the answer was like 40.27 deer. I've seen 40 deer before, easily. I've never seen like what 0.27 of a deer would look like. Like, would it be and then you wonder, like, is it just like one leg of a deer with like a little bit more? Is the head included, or do they take it do they cut the deer with the 0.27 deer from the side? The whole problem that you go through here. Put them into actual context. Go through right now, please, and read and do out question number 4. Looking at what's there to start, Johannes, what would you give as your equation for A?
I equals 30x plus 50.
The 50 is the base or fixed amount. The 30 is the hourly rate. That's what's going to be increasing as the clock runs. If a car repair costs 225 hours, how many hours did it take? Noah, what equation would you set up for that one?
125 equals 30x plus 50.
And can you keep going so we can solve that out?
Then you would subtract 50.
So how much do you have if you got 125 minus 50?
75.
So we've got 75 is equal to 30x. I'm going to divide both sides by 30. Go over, this is a trick. I don't know if some of you learned it. The Calc kids taught me this last year. Make sure again, please, that you go in and sign into your calculators. So as we do this one, magic one, our presenter. Go in right now, please. So you've got the 75 that's there, and it's going to be 75 divided by what in this case? Was it 30? Okay, so go in and type in 75 over 30, and it's going to give you out some reduced fraction when you hit enter. Do this now. Go through and press Control Division. Go through and press Control Division, because that's going to set you up with a fraction to begin with. In the numerator, type in 75, and in the denominator, type in 30 with a dot after it, and that's going to give you out the answer as a decimal.
You can just hit Control Enter.
Control Enter on it as well? Okay. So, how many hours did this end up being? Well, we would go through and say that x is equal to 2.5. Let's bounce over questions on this one. Let's bounce over and try the next one. And this is our last one. A mug that has 2 ounces of coffee and it weighs that amount. The same mug with 6 ounces of coffee weighs that amount. Write a linear function that expresses the weight of the mug as a function of the number of ounces. Now, this is useful, and you do this frequently if you're not able to literally take something and put it on a scale. You can take its weight when it's full of two different amounts, and then you can work backwards to find out what the original weight is using this linear relationship that's here. We need to write a linear function that expresses the weight of the mug, which is the y, as a function as the number of fluid ounces that we'd have. Well, if you're asking to give out a linear function, the first thing I would need to go through and do is recognize I'm probably going to use y minus. I don't have my y-intercept, so y minus y1 is equal to m times the quantity x minus x1. Let's see. So, Trevor P., what do I need to find that I don't currently have?
You need to find the original slope.
The slope. Do you have enough information to find the slope?
Yeah.
What would you use, Trevor, to go through and find that slope?
We do change y over changing x.
Good. So which ones do you want to list out first?
We do 1.4 minus 20.6.
Okay. Then in the denominator, what would you have?
6 minus 2.
So if you go into your calculators, you can do out control division, then type in the numerator over the denominator. Hands up, please, when you can tell me what that is as a fraction. We've got one person. Terrific. You can give us a fraction or a decimal. I don't care. Which one do you want to give? Okay, what'd you get? 0.2. All right. So knowing that, now let's finish this off. And Taylor F., what would you go through and give out as your linear relationship? What's that? Yeah. And you can use whichever point you want. Okay? Now, this is right except for one thing. Something on here needs to change. Go ahead. Yeah, it's always minus those amounts if they're positive, because it's the opposite sign of what's there, but they're in the right position. Questions on that? Now, the last thing you need to do is figure out the weight of the empty mug. And how can you figure out the weight of the mug when it's empty? One person, two? Please give me a sec.
So pretty much what you do is you take the point slope formula that you got in 5a, and then substitute the x for a 0, and then solve for y.
Perfect. We're going to go through. This is going to be y minus 0.6 is equal to 0.2. The x right here represents the number of ounces in it. So we're going to replace that with a 0. Now go through and finish solving this out on your own. Go through, please, finish this and solve it out on your own. And I'll send you out the question through the calculators.
Do we just have to put in the number? Or do we
Yep. You don't need the units, just the number. Got 9 of us, 10 out of 24. $17, 18, 19, go back down to 18 somehow. Go through and enter it if you haven't. 20. 21. Sitting there. So this one and this one's right. So 19, not bad. When we do this out, we would distribute, this is going to be y minus 0.6 is equal to, this would be 0.2 times negative 2, which would be negative 0.4. From here, I go through and add 0.6 to both sides, which means I would be left with y equals 0.2. Questions on that? Now, your homework for next time, we ask that you do it out, please, on separate paper. Make sure your name is at the top with the -1. If you get stuck, stop and ask. It's not going to be an issue. Oh, there's one other thing. I'm sorry. Isn't there one more on the next page? Sorry. Go through, take a look at what's there. Which ones of these represent linear functions? Hands up, please, when you can tell me one of them that's going to represent a linear function. Think about what they look like. A is going to be a linear function. This is going to be y is equal to 6. It's always a y value of 6. There's one more that's linear. What's the other one that's linear? D. There you go. So let's circle D. Now we're done. Sorry. So your homework is in there. I'm not going to give you the book. If you need a bigger version of those questions, it'll be posted through that class. And the other thing that you all need to remember, who has finished their Math Excel assignments? Okay, how long did it take? Like 6 minutes? Weren't the questions like if the answer's 5, type in 5? Yeah, and this is a fraction, etc. So, sometimes you'll get assignments that are assigned through it. We'll let you know and we'll give you a couple of days to do it. But don't dawdle and don't wait to get them done. If you don't, if there's, you can do it while you're at school. Make sure, one more thing. Look at the number on the back of your calculator. There's a number over on the side. Those numbers need to match. Calculator 5 needs to go in spot 5, please. Go hand those guys back in. Have a great rest of your day.
Is that Math Excel graded?
Yeah, it goes in, but it's going to go in as like an assessment, and this one will be like 5 points.
on the calendar.
So annoying.
Why?
I did it, and I kept putting the right answer in, right?
It's just a completion of it. Well, wait a minute. You know, I always say this, if there's ever an issue where, like, sometimes it will look like you'll write in y equals 5 or something, and you'll type in a 5 and says, the right answer is 5, you put in 5. Take a picture of it and show it to me. We'll adjust the mark. But what was it doing that was...
I was like doing it with a dotted line.
To construct a graph?
Yeah.
I only give the ones that are algebra based, you know what I'm saying? Like, so the answer would be 2, not draw this line on it. Is that what it was asking you to do?
Yeah.
Okay, I don't give those out when we do regular assessments.
Okay, thank you.
Yep.
What? It's all right here. Oh, that's it? Just like 5 problems? There's a bit more after. Actually,